What if I told you every price level on this chart was calculated before the market even moved? The answer lies inside Gann's square of 9. But how can you read what it's trying to tell you? What makes these price levels so precise? The answer is hidden inside this table. Why did Gann arrange numbers like this? To understand the square of 9, we must first understand Gann's thinking. Before we begin, here is a financial disclaimer. This content is for educational purposes only and does not constitute financial advice. Trading futures and options involves substantial risk and is not suitable for every investor. Trading involves risk, and you may lose capital. Always conduct your own research before making financial decisions. Let's start at the beginning. Every trading session creates new highs, new lows, and countless price levels. To most traders, these numbers simply become part of the chart. But what if they aren't just random numbers? What if every price occupies a precise mathematical position? When price reaches a new level, the usual response is to draw a trend line, add an indicator, or search for a chart pattern. The analysis always begins after price has already moved. Gann wasn't interested in reacting to price. His objective was to understand whether mathematics could reveal important price levels before the market reached them. Imagine looking at a chart without asking, where's support? Instead, you ask, why should support exist at this exact price and nowhere else? That small shift in perspective changes the entire problem. If markets follow any underlying order, then price shouldn't behave like a collection of unrelated numbers. There should be relationships connecting one level to another, relationships that can be measured, tested, and repeated. Rather than starting with indicators or chart patterns, Gann went back to something much more fundamental, numbers themselves. If there was a hidden structure behind price, he believed it would first appear in mathematics. Think about it for a moment. At its core, every chart is nothing more than time and price. Every candle records where the market was and when it was there. If there is an underlying structure governing market behavior, it must be hidden within these two dimensions. Let's begin with another simple question. Suppose we write the natural numbers in the familiar order shown on the screen. This arrangement makes counting straightforward because every new number simply follows the previous one. The equation shown here is the mathematical definition of that sequence. The symbol sub n represents the value of the nth term in the sequence, while n represents the position of that term. In other words, if the position is 1, the value is 1. If the position is 10, the value is 10. Every term is exactly equal to its position. This formula describes a perfectly ordered counting sequence, but that is all it does. It tells us nothing about direction, rotation, distance, or geometry. It is a rule for arithmetic, not a framework for spatial relationships. Now consider the two equations shown on the screen. Although they look completely different, they describe exactly the same complex number. In the first equation, x represents the horizontal component, y represents the vertical component, and I is the imaginary unit that allows us to describe two-dimensional numbers. The second equation expresses the very same number in a different way. Here, r represents the distance of the number from the origin, while the Greek letter theta represents its angle of rotation. Notice what has happened. The number itself has not changed. Only its mathematical representation has changed. The first equation emphasizes position along two axes, while the second emphasizes distance and angle. This is an important mathematical principle because changing the representation often reveals relationships that were difficult to recognize before. Gann applied exactly the same principle to the natural numbers. Instead of creating new numbers or inventing a different mathematical system, he kept the numbers exactly as they were. The only thing he changed was the way they were arranged. His reasoning was straightforward. If changing the representation of a complex number can reveal new mathematical properties, perhaps changing the representation of the natural numbers can reveal new numerical relationships as well. This idea became the foundation of the square of 9. Once numbers are placed in two-dimensional space, geometry becomes possible. The equation shown on the screen is known as the distance formula. It calculates the straight line distance between any 2 points on a coordinate plane. The symbols x1 and y1 represent the coordinates of the first point, while x2 and y2 represent the coordinates of the second point. The equation first measures the horizontal difference and the vertical difference between the 2 points. Those differences are then squared, added together, and finally the square root is taken to produce the true distance between them. Notice that this equation only works after every object has a position in space. A simple list of numbers has no coordinates, so this type of measurement is impossible. Geometry begins only when numbers are given a location. The square of 9 follows exactly this mathematical philosophy. It does not change the natural numbers or the rules of arithmetic. Instead, it assigns every number a specific geometric position relative to a common center. Once every number has a position, relationships can be studied using geometry as well as arithmetic. Numbers can now be compared by their direction, their angular separation, and their distance from one another. The mathematics remains the same, but the geometric organization reveals patterns that cannot be seen in a simple numerical sequence. That is the idea we will now build step by step. Now, let's examine the structure of the square of 9. At first glance, it may appear to be a random arrangement of numbers, but every position follows a precise mathematical order. The number 1 occupies the center, and from that point the natural numbers expand outward in successive square rings. Unlike a simple numerical list, every number now has both a numerical value and a geometric position. The easiest way to understand the square of 9 is to think of it as a series of expanding square rings. The center contains the first number, and every new ring surrounds the previous one, increasing the size of the structure. Each ring contains a unique group of numbers and represents a new level within the table. Since every ring has a fixed position, we can identify exactly where a number belongs simply by determining the ring in which it is located. This concept becomes extremely useful because many square of 9 calculations begin by identifying a number's ring before performing any further analysis. Now notice that the square of 9 can also be divided into 8 principal directions. These directions act as the primary reference axes of the table. Every number lies somewhere along one of these directions or between them. Instead of thinking only about whether a number is larger or smaller, we also begin thinking about where it is positioned relative to the center. These directional relationships form the basis for angular analysis. As we continue, these 8 directions will allow us to measure important geometric intervals such as 45 degrees, 90 degrees, 180 degrees, and 360 degrees. Now, let's examine one of the most important patterns within the square of 9. The highlighted diagonal contains the sequence of odd perfect squares: 1, 9, 25, 49, 81, 121, and so on. Every completed ring ends at an odd perfect square, causing these numbers to align naturally along the same diagonal. This relationship can also be expressed like this. Start by taking the ring number, multiply it by 2, then add 1. Finally, square the result. The value you obtain is the odd perfect square that marks the end of that completed ring. For example, when the ring number is 0, the result is 1. For the first ring, the result is 9. For the second ring, it becomes 25, followed by 49, 81, and so on. In other words, every completed ring ends at an odd perfect square. Understanding the structure is only the first step. The real question is how we can use square of 9 to find market reversals. Let's walk through a complete real market example. The asset shown here is Bitcoin against Tether on the daily chart. We begin by identifying a completed upward movement. The market forms an important low on Friday, the 21st of November, 2025. From that low, Bitcoin rallies approximately 21.34% before creating a significant swing high on Wednesday, the 14th of January, 2026. The first step is measuring the completed percentage move. In this example, the advance measures approximately 21.34%. Instead of working directly with decimals, we normalize the value. We multiply the percentage by 100, converting it into the whole number 2,134. Normalization simply removes the decimal while preserving the same mathematical relationship. Now, we calculate the square root of a normalized value. The square root of 2,134 is approximately 46.2. Since the square of 9 is organized using whole numbers, we begin from the nearest whole value. That gives us our starting number 46. Now comes the important part. Instead of performing additional arithmetic, we move to the square of 9 itself. We locate the number 46 inside the table. This number now becomes our reference point for all future projections. Everything from this point forward is based on the geometric structure of the square of 9 rather than the original percentage movement. Notice where 46 is located. Once we identify its position inside the square of 9, we no longer focus on the percentage move itself. Our attention shifts entirely to the geometric relationships surrounding this number. These relationships allow us to project future timing windows directly from the square of 9. Rather than making a prediction immediately, we now allow the market to reveal whether this mathematical relationship has any practical significance. The next step is projecting the first future date generated from this position on the square of 9. Using the square of 9 progression, the first projected timing window falls 46 calendar days after the swing high. That projection lands on 1st of March, 2026. Notice that this projection is calculated before observing any future price action. The market has not yet reached this date. Everything beyond this point is unknown. Now we simply wait. As the market approaches the projected timing window, we observe how price behaves. Notice that Bitcoin experiences a significant decline before arriving at the projected date. At this stage, we are not expecting the exact low to occur precisely on the projection. Instead, we are interested in whether the market begins responding around this mathematical timing window. As Bitcoin reaches the projected date of Sunday, the 1st of March, 2026, something interesting begins to happen. Selling pressure slows. The market stops making aggressive declines. Buyers begin stepping into the market. This is the first indication that the projected timing window may be producing a measurable market response. Notice what develops after the projection. Instead of producing only a single bullish candle, Bitcoin begins forming a series of higher lows and higher highs. Buying pressure continues for several weeks. This is an important distinction. The projection does not simply identify one reversal candle. It identifies the beginning of a sustained bullish reaction. The first projection, therefore, serves an important purpose. Rather than marking the final trend reversal, it introduces a change in market behavior. Selling pressure begins to weaken. Accumulation begins to develop. The market starts building the foundation for a larger advance. We can also skip the projection of first harmonic. It's up to you whether you want to catch trades there or wait. Once the first reaction has been established, we continue the same process. Using the square of 9 progression, we calculate the next projected timing window. The second projection occurs 77 calendar days after the original swing high. This projection falls on Wednesday, the 1st of April, 2026. Again, notice the behavior around the projected date. By the time Bitcoin reaches the second projection, the bullish structure established after the first projection is already in place. Instead of reversing downward, the market resumes its advance with renewed strength. The existing bullish trend continues to expand. This shows another important principle. Not every projection produces a major reversal. Some projections reinforce the current trend. In this example, the second projection acts as a continuation point, allowing the existing bullish trend to maintain momentum. The market now advances steadily after the second projection. Higher highs continue forming. Buying pressure remains dominant. The bullish trend matures over the following several weeks. The next step is calculating the third projection. Following the square of 9 sequence, the third timing window occurs 116 calendar days after the original swing high. This projection falls on Sunday, the 10th of May, 2026. As Bitcoin approaches the third projection, notice the condition of the market. The bullish trend has already been advancing for a considerable period. Momentum remains positive. However, extended trends eventually begin losing strength. The question now becomes whether this projection will produce another continuation or signal exhaustion. Observe what happens as price reaches 10th of May, 2026. The market forms a significant swing high. Buying pressure begins to weaken. Momentum slows noticeably. This projected timing window coincides with the exhaustion phase of the bullish trend. Following the third projection, Bitcoin begins a sustained decline. The market transitions from higher highs into lower highs. Selling pressure gradually replaces buying pressure. The trend that began developing after the first projection has now reached maturity. Let's look at another real market example. This time we'll use the British pound against the US dollar on the 4-hour time frame. First, we'll identify a significant swing low and the corresponding swing high. These 2 points will serve as the foundation for our entire calculation. To speed up the process, I've created this spreadsheet that performs all of the calculations automatically. Instead of calculating everything manually every time, I simply enter the swing low and the swing high into the spreadsheet. It immediately calculates the percentage move, normalizes the value, takes the square root, and provides the starting number that we'll use for the square of 9. In this example, the square root is approximately 12.69, so we'll use 12 as our starting number. Now we move over to the square of 9 table. Since our starting number is 12, we first locate 12 on the square. Once we've found it, we immediately focus on the horizontal row passing through that number. This highlighted row becomes our harmonic pathway. Once we've located our starting number on the square of 9, the next step is selecting the projection path. The square of 9 allows us to project values using different paths. In this method, we'll use the linear projection path, which follows the numbers immediately adjacent to the starting number along the same axis. We simply continue along this sequence, and each number becomes the next harmonic projection used for our future time calculations. We now convert those harmonic values into time intervals and project them forward from the swing high. Each vertical line represents one harmonic projection generated directly from the highlighted row of the square of 9. As price unfolds, notice how several of these projected intervals align remarkably well with important turning points. These reaction windows weren't drawn after the fact. They were projected in advance using nothing more than the measured swing, the normalized calculation, and the harmonic sequence from the square of 9. This is how we extend the vibration of a completed market move into future time projections. If you'd like to use this calculator yourself, I'll be giving the spreadsheet away completely free inside my Telegram community. You can join the group using the link in the description and download your copy. Let's stop for a moment and ask an important question. Throughout this method, we've measured the market move, normalized it, and then immediately taken the square root. But why? Why don't we use the normalized value directly? To answer that, we first need to understand how the square of 9 itself is organized. Notice this familiar sequence of perfect squares. Every one of these numbers is created by multiplying a number by itself. In mathematics, taking the square root simply reverses that process. It allows us to move from a square value back to its original root. This relationship is the foundation of the square of 9. Suppose we choose the number 49. Its square root is 7. The important observation is that every perfect square has a corresponding root. The square of 9 is built around this relationship. Instead of viewing numbers as isolated values, it organizes them according to their square root progression. Now think about our market move. After normalization, we obtain a large numerical value. However, that number has no direct location inside the square of 9. Taking the square root transforms the market measurement into a value that can be used as a reference point within the square of 9 structure. Imagine receiving the street number of a house without knowing which road it belongs to. The number alone isn't enough to find the location. The square root plays a similar role. It converts the measurement into a reference that tells us where to begin inside the square of 9. Now, let's ask another question. Why don't we simply locate the normalized value itself on the square of 9? The answer is straightforward. Large normalized values vary significantly from one market move to another and are far removed from the geometric relationships that define the square of 9. The square root compresses that information into a meaningful reference while preserving its mathematical relationship. Notice what has happened. A very large number has been transformed into a much smaller one. Yet no information has been discarded. The square root is a mathematical transformation, not an approximation. The relationship between the original value and its root remains exact. Once we obtain the square root, we can immediately locate that value inside the square of 9. That location becomes the origin of our harmonic projection. From there, we no longer work with the original market move. Instead, we work with the geometric relationships surrounding its root. One of Gann's central ideas was that markets could be studied through mathematical relationships rather than isolated prices. The square of 9 reflects this philosophy. By transforming the market move into its square root, we shift from arithmetic measurement to geometric organization. That is what allows the square of 9 to be used as a forecasting tool. The important idea to remember is this. We do not take the square root because it is an arbitrary step. We take the square root because the square of 9 is fundamentally organized around square root progression. The normalized market move gives us the measurement, while the square root gives us the correct position within the geometric structure. Once that position is known, the square of 9 can be used to generate future harmonic projections. So far, we've been using price to generate our square of 9 starting number. We measured the market move, applied our mathematical transformation, and projected future timing. But what if price isn't the only source of information? What if another measurable quantity could also generate a valid starting number? What if we used a planet instead of price? Let's think about this for a moment. Every planet occupies a precise longitude at every instant in time. That longitude is nothing more than a numerical measurement, just like price. If we can transform price into a square of 9 starting number, could we apply a similar idea to planetary longitude? But there's one problem. At first glance, it seems simple. Suppose Mars is positioned at 218 degrees. Should we simply locate 218 on the square of 9? Not quite. Unlike price, planetary longitude is cyclical. Every planet eventually completes a full revolution and begins the cycle again. That means we need to account for its repeating nature before using it. So what really matters? Instead of asking where the planet is within the entire 360-degree circle, perhaps a better question is this: where is the planet within its current harmonic cycle? Since a circle naturally divides into 4 equal sections of 90 degrees, we can focus on the planet's position inside its current 90-degree segment. In this example, we will analyze the soybean market using the daily time frame. As with every analysis, the first step is selecting our astronomical reference point. For this soybean example, the reference date is the 12th of March, 2026. On this date, Mercury has been selected as the reference planet because it provides the strongest harmonic relationship for this particular study. According to the planetary longitude calculator, Mercury occupies a longitude of approximately 341.99 degrees. This longitude becomes our fixed starting coordinate, and every future calculation throughout this example will originate from this single planetary position. The next step is to convert Mercury's longitude into its primary harmonic equivalent. Since soybean is being analyzed using the 180-degree harmonic cycle, complete 180-degree rotations are removed from the planetary longitude. After performing the harmonic reduction, Mercury's longitude of approximately 342 degrees becomes approximately 162 degrees. Once the harmonic longitude has been obtained, we perform the square root transformation. This is one of the most important mathematical steps because the square of 9 operates through square root relationships. Taking the square root of the reduced harmonic longitude produces a value of approximately 12.73. The transform value must now be converted into a practical square of 9 coordinate. Since the calculated value is approximately 12.73, we round it to the nearest whole number, producing the value 13. This number is extremely important because it becomes the starting coordinate from which every future harmonic interval will be projected. Having determined the starting coordinate, we now locate the number 13 on the square of 9 chart. The highlighted position represents the exact location generated by Mercury's longitude after harmonic reduction and square root transformation. Using the starting coordinate, we now begin projecting future harmonic intervals across time. Each projected interval represents another expansion of the same planetary vibration. Rather than selecting future dates randomly, every interval is mathematically derived from the original coordinate generated by Mercury's longitude. This creates a sequence of objective timing windows where significant market reactions become more important. The market now reaches the first projected harmonic interval. At this stage, we are not attempting to predict direction in advance. Instead, we carefully observe how price behaves as it enters the projected timing window. Notice that the market begins producing a constructive bullish reaction shortly after reaching the interval. Following confirmation, the bullish movement continues to expand. This illustrates an important distinction between timing and direction. The harmonic interval identifies when an important reaction is likely to occur, while price action determines whether that reaction develops into a bullish continuation or a bearish reversal. By combining harmonic timing with market structure, the probability of selecting meaningful trading opportunities improves considerably. With the first projection completed, our attention now shifts toward the second harmonic interval. Notice that no new planetary calculations are required. The same Mercury longitude selected at the beginning of the analysis continues generating future timing windows through harmonic progression. This demonstrates the consistency and repeatability of the methodology across an extended period of market activity. As soybean approaches the second projected interval, bearish pressure begins appearing within the market. Once again, the interval itself does not create the reversal. Instead, it identifies the period where price becomes highly sensitive to existing market forces. After confirmation appears through price action, the market transitions into a sustained bearish movement. The bearish decline continues developing after the second harmonic interval, providing another successful example of harmonic timing. By this stage, we have already observed both bullish and bearish reactions generated from the same planetary coordinate. This reinforces the concept that harmonic timing identifies periods of elevated probability rather than predicting a fixed market direction. We now continue to the third projected interval generated from the original Mercury calculation. Because every interval originates from the same starting coordinate, the mathematical consistency of the methodology remains intact. The planetary calculation performed at the beginning continues projecting future timing opportunities without requiring any further astronomical adjustments. As price approaches the third harmonic interval, another significant reaction begins developing. Once again, confirmation is obtained directly from market structure rather than assumption. This repeated behavior illustrates that harmonic timing is capable of identifying multiple high-probability trading opportunities from a single planetary reference point. The indicator and research software used throughout this course is my proprietary software, developed through years of market research and practical application. It is not publicly available and is provided exclusively to serious traders enrolled in my private mentorship. These charts shown here are actual examples of work completed by students during the mentorship. The Gann Astro Private Teachings is a structured market research and professional trading education program delivered over approximately 12 to 20 weeks. Students progressively learn swing trading, intraday trading, astro timing, price delivery algorithms, market geometry, sacred geometry, time cycles, planetary degrees, and advanced Gann techniques through weekly lessons, practical assignments, and live market observation. Learning does not end after each lesson. Every student's progress is monitored throughout the program with regular assignment reviews, personalized feedback, practical chart discussions, and dedicated doubt-solving sessions. Each topic is fully understood before progressing to more advanced concepts. The most successful students in my private mentorship all share one common habit: disciplined research. Many have personally documented hundreds, and in some cases thousands, of market charts while studying live price action. For more valuable Gann research, educational content, and market insights, join our free Telegram group. The link is available in the video description. Why don't we use the planetary longitude directly? One of the most common questions is why we don't simply locate the planet's longitude directly on the square of 9. After all, the longitude is already a numerical value. The reason is that planetary longitude and the square of 9 describe numbers in two completely different mathematical domains. Before a planetary angle can be interpreted using the square of 9, it must first be transformed into a compatible numerical vibration. That transformation creates the mathematical bridge between planetary geometry and the square of 9. Planetary motion is cyclical. Once a planet completes a full revolution, the cycle begins again. Harmonic reduction allows us to express the longitude within a specific harmonic framework instead of treating every revolution as entirely different. Whether we use a 90-degree, 180-degree, or 360-degree harmonic depends on the research methodology being applied. The purpose is to isolate the harmonic position before performing any further calculations. The square of 9 is fundamentally based on square root progression. Adjacent numbers, rings, and angular relationships can all be expressed through square root mathematics. Taking the square root is not an arbitrary calculation. It converts the harmonic angle into a numerical vibration that naturally fits the mathematical structure of the square of 9, allowing us to identify a logical starting coordinate. Planetary longitude produces continuous values containing decimal places, while the square of 9 is constructed using whole numbers. Since every position within the square of 9 corresponds to an integer, the transformed value must be converted into the nearest whole number before it can be located on the spiral. This creates a practical starting point while remaining consistent with the structure of the square of 9. Another common misunderstanding is that harmonic timing should predict whether the market will move higher or lower. That is not the objective of this methodology. The purpose is to identify periods where market timing becomes significant. Once the projected interval is reached, price action, market structure, and other analytical tools determine the direction. Harmonic timing answers when, while price analysis answers what. Imagine a point moving around a circle. At every position, that point has both a horizontal movement and a vertical movement. Even though we describe the planet using only one angle, that angle actually contains two independent geometric components. If we could separate those components, perhaps we could reveal information that isn't immediately visible from the longitude alone. One of the primary purposes of trigonometry is to resolve an angle into its horizontal and vertical components. The cosine function measures the horizontal projection of an angle, while the sine function measures its vertical projection. Together, these two functions completely describe the position of a point on a circle. Instead of treating planetary longitude as a single value, we can study both of its harmonic components independently.